Okay, so question number 4. How do you calculate the number of moles from volume? Okay, so they didn't really specify any other variables that are given, so I'll just go over all the different options that I can think of how one would calculate the number of moles when given volume. So there's different scenarios, so we can have for solutions, if we are given concentration and we're also given volume, then we can calculate for number of moles. So concentration is equal to number of moles over volume. So we can rearrange this equation and solve for number of moles by multiplying concentration times volume. So that's one of the simpler scenarios. Another scenario is if we are given density and volume. So for maybe solids, let's recall that density is equal to mass over volume. So we can rearrange this equation and solve for the mass by just multiplying the density and then the volume of the solid. And then once we're given mass, then we can solve for number of moles, because number of moles is equal to the mass over the molar mass of the substance. So this is another option. It's 2 steps. It's another way you can find number of moles. And then another option that could be used, which is less likely, is if you have an ideal gas. So the reason I say that this is less likely for the question is that we need other variables involved. So I'll show why. Because if we have the ideal gas equation, PV equals nRT, not only do we need volume, we'd also need the pressure of the system. R is just the ideal gas constant. So this is already known, but we would also need temperature. And V is the volume of the gas in the system. But still, if we are given all of these different conditions, then we could still potentially solve for number of moles of the gas by multiplying pressure times volume and dividing it by R and temperature. This is another scenario that is likely. So let's see what the junior tutor said. It will depend on the problem. Consider 2 cases. 1, given the volume and density of the sample. 2, given molarity and volume of the sample. First case, given volume and density. Density of a substance is equal to the mass present in the sample per unit volume. In the equation, density is equal to mass over volume. Remember to put the units of volume to liters if it is in terms of milliliters. And then the mass of the sample can be calculated via multiplying density and volume. Mass of the substance is related to the number of moles of the substance. And then they show that molar mass is equal to mass over number of moles. And then from this, you can solve for the value of the number of moles by dividing mass over molar mass. And then they just combined the two equations to show how one would do that. Second case, given molarity and volume, they have molarity or concentration is equal to number of moles over the volume. To find number of moles, you would calculate concentration and volume. So this solution is correct. I'll also add if we had an ideal gas. Or a gas behaving ideally if pressure and temperature are also given. So I said another scenario is if you have a gas behaving ideally, if pressure and temperature are also given, we can calculate the volume of gas by rearranging the ideal gas equation. Or number of moles of the gas.